So please take a seat. The Opsec working group meeting starts. My name is Eric Vink, and my colleague in crime is Günther van der Veld. We have already a minute taker. KK is doing it. We are looking for a JavaScribe. Nobody wants to be a JavaScribe? Okay. Thank you. Thank you, Joel. And you, second time you are doing it for us, if not mistaken. Thank you. So we've got the JavaScribe, we have the minute taker, the Note well. By now you should know. By the way, I'm never reading them personally, make mistakes, so from time to time, please be sure to read it, else you never know. But basically it says whatever you say here is public and whatever. Blue sheets, Günther is secreting them. Don't forget that's pretty important, so next time we will get a large, bigger room, right, because we need it. You know, like in the plane, right, to be sleeping on multiple chairs. Anyway. Agenda, more seriously. So the administrator, that's what we are doing. And you will notice that we have invited speakers to talk here, even if their draft is not in the Opsec. The reason is that quite often we have a draft that are doing some operational and security issue, even if they are not in the Opsec working group. So it's important that operational security people like us and security people like us provide feedback to them, and all those authors are quite happy and looking forward for it. So we do it with Susan Ayers. We talk about an Opsec draft with Mary Kay, the operational security consideration for IPv6 network. We continue with Bernie about how we can secure the exchange between a DHCP relay and a DHCP server. Of course, Jérôme François will talk how we can signal DOS attack over V6 by using hop by hop, which is, looking at the faces some people in the room, is interesting proposal. And then we finish with Richard Barnes explaining quickly this automatic certificate management environment, also known as ACME, which is basically used by Let's Encrypt, which has fundamentally changed how we operate securely network, in my opinion, there. Administralia. As you notice by the email volume, the mailing list, it's a quite working group. We currently have only 2 active working group documents. The one about IPv6 extension header filtering by Fernand Nagant. For me, it's reached quite a stable state. At least a lot of recommendation, what to do in which case, with which extension headers. My understanding is Fernando is not here, but it would be nice next time to go forward with it. Mary Kay will present the operational security later today. We also have another active document that has never been presented to the working group about unicast RPF checks improvement. In short, it has mainly been discussed on the GROW working group, because that's again something which is crossing 2 working groups. But in short, it's about, we all know about unicast RPF check in strict mode and one in loose mode. This proposed something in the middle. Okay. There is nothing into the ISG processing queue, and there is no other document as far as I know. So, first session. Is Sue RS here? Is somebody you? Yeah. So, Mrs. Sue, that's for you.
Hi. So I will present briefly. It's a draft about the security environment for I2RS. Well, I guess that's the reason it's presented here. So we came with a few, so it's not a protocol requirements, but only about the environment. So basically it's providing some requirements, some attention when you're willing to deploy I2RS. So we came with 37 requirements. We can divide them into 3 categories: isolation of the system management, and the remaining of the system. We have interplane isolation for access control and for application I2RS applications. So are you aware of the I2RS architecture?
I think it would be better to make a refresh.
Okay. So basically you have applications that are connected to one I2RS client, and you can have multiple applications, and the client is communicating to the I2RS agent, which is in charge to update the routing states of the data plane. So here is so you have the application, the client, the agent, well, an important thing is that you can have multiple applications to one I2RS client, which means that the agent may not really see which application is providing some instructions. So, we have, so we came with different planes, one which is the data plane, the control plane, and the management plane. So one of the, some of the requirements are how to isolate all these planes. This is what I mentioned about the I2RS architecture. So you can have multiple applications connected to one client, but you can also have one client connected to multiple agents. So you have all the possible combinations. Some of the requirements are, because you can, well, you have all these indirections. So some of the requirements are which application are bind to which I2RS client, and so on, which I2RS client to. So some of the requirements as well, if you're clustering all these applications, and well, you should cluster them according to the privilege you have. If you have multiple applications that can access to a given client and they don't have the same kind of privilege, then you can easily, leak, end up into a privilege escalation situation. So that's the reason we asked to cluster the applications according to the privileges. So that's what I just said. Well, I think so. That's all about the escalation. Is that the last slide?
And there was only 15 slides, which was quite short.
Okay. So I don't know if there are any question. So that's the last slide, or something?
No, nothing prevents you to tell more. And strictly one thing that's interesting for me, it's how you provision everything.
So, so how we provision, that's probably, so it's part of the management.
Mm-hmm.
And so I don't see the link with security. So, well, basically you would like to avoid a situation where one tenant is, okay. So how we provision, so is the question how we maintain that the different tenants remain isolated, or because
Maybe I can help you out with that. Okay. Sorry, I guess I had the wrong time. So in many cases, when we provision these pieces, right? First of all, is the context this slide?
In general.
Pardon?
In general.
Oh, in general. Okay. So remember, this is all in the context of the IR2S agent and the alternate data stores. The IR2S agent is a dynamic control plane that uses netconf, restconf. And so our initial protocol that's doing general provisioning talks to a piece of software on the router or the device, and it basically says, do these things. So that's a provisioning agent, which you can think of just like netconf, restconf, because we are using, our protocol to use is restconf. Our data models are data models, but they can exist in a new data plane called it's in the revised data store data plane. It's a control plane data plane. So when you see that, you'll see several times IR2S. The security piece here is okay, so when you have that protocol agent, just like when you have a netconf server that's sitting on a box, that's actually an implementation. And that implementation has some extra things, but that's how you actually implemented it. You have the netconf server client environment. It's just a server. To disambiguate it from the control plane use is called the IR2S agent. This ancillary security that this draft references is really the notes to the implementers, which Daniel started with, that says this is what we think you want to do when you write on it. They're written as requirements in the draft, but they're really a suggestion of helpful things that requirements in the sense, please, these are good things if you want to make sure things don't have security problems. They're not the type of requirements like you'd have on the RESTCONF protocol. That's a whole other spec. This is just, these would be really good things. If you think that we should really restate them as these are general, really good ideas, we can respin it as, these are really a list of really good things. But I'm sure Daniel would have said that in the beginning if I hadn't. Did we answer the question for you?
Yeah, thank you. Any other questions from the room?
With the chair's permission, may I ask a question?
Is
To the room, is this the sort of thing that you want to hear about in Opsec? Are these things that, as we get new protocols, that are useful for you? Anybody think this is really good you want to know about in the future?
Let me ask for a hammer. Maybe it is more discreet, right? So I will ask the question twice. Of course, first one, who think it was useful to get this kind of discussion here? And who think it's a waste of time, just to be brutal, right? And knowing. So let's go for the hum. Who think that this kind of presentation, specifically this one, is useful? Please now. For the people that think that it's a waste of time, again, to be brutal, please now.
Okay.
Okay.
Well, thank you. We'll give you more.
Okay, thank you. Thank you, Daniel. Thank you, Sue.
Thank you, Miguel, for doing it.
So, mm, so next one is Mary Kay. I seen you enter. And by the way, as you see, I'm a co-author, so we have only one chairman now, right? This will be Gunther for a while.
You have a clicker thing here if you find it easy.
Hello. So this is a draft that the three of us, Eric, KK, and myself, started about 4 years ago. And part of it was because with the V6 security, all of the recommendations and what you have to consider was in about 100 different RFCs. So we decided probably better to create one single document so that if somebody was looking at how do you secure V6 and what are the considerations, that you had one document to look at, and we created a synopsis. So that's kind of the impetus of why this work got started. We are at revision 10, and I just want to show some of the latest updates. There was some considerable review done by some folks from the V6 Ops community, and so we're very grateful and thankful for that. So there were some threads June of last year, and so that led to a bunch of fixes. Primarily, it was fixing grammar issues and spelling errors, adding links to provide more explicit references, also being consistent with uppercase and lowercase cases used for acronyms. We corrected a reference in some sections, and we updated all the references because some of the drafts keep getting updated, obviously, or some that turned into RFCs in the 4 years that we've been working on this document. And we also finally added some explicit language to replace some of the TBDs. And so specifically the extension header. So we added some text on how to handle and what considerations there should be for extension headers. The first bullet point I think is really important, right? There's a herd mentality in terms of drop every packet that has an extension header. That is not practical. And so I want to make that statement offhand. So we added explicit text to show that extension headers are used in operational networks. And so you really need to think about, do you need them, right? And you have to think about, should you be dropping some of them or not? And then what else can you do? So we first list some operational aspects, and primarily it's the IPsec, either AH or ESP extension headers or fragmentation that you really need to think carefully about and how or whether or not they're all utilized. We talk about order and repetition, the hop-by-hop extension header, which has some DOS, DDoS aspects for consideration, and then the fragmentation extension header, because some specific fragments could cause stateless filtering bypass. So we also added language for external security considerations, so specifically a language to address current work in progress for extension header filtering, as well as new language in that specific draft. So we have the reference for the draft. It's actually a draft in this working group. I'm not going to read the text. I think you can read it for yourself. But we added that to be more explicit and, of course, up to date with all the current work and considerations that you need to think about in securing V6 networks. So next steps, we want to thank Marcus and Fred, who provided extensive information and comments back in June 2016. And we would like to ask the working group whether or not this document is ready for last call. Those pictures were taken at 8 in the morning when we met for breakfast to finalize these slides and going, are we done yet? And those of you that might know me, I'm not a morning person at all. So
I can testify this morning it was a slow start.
Yeah, I'm always late in the mornings. But anyway, so yes, so that's it for the presentation part, and we would like to solicit feedback as to whether or not folks think that this document is ready for last call. How many of you have read the document?
Okay. Yeah, yeah. Yeah, indeed. So we started this journey about 4 years ago, and I think it is about time to start thinking about closing this piece of work. So also in the previous time we gathered, we already came to the conclusion that that we were going to work upon a working group last call for this. After the document was updated, now that took a while, and the working group last call never happened. So right now, at this point in time, do you actually think that the document is ready for working group last call? Or-
We have, as the authors do, I mean, we had some life, happen. But and we didn't even really plan to all three be here at this meeting, but it just so happened. And so, but we do feel like it's ready for last call. It's a document where as new things come up, it can last forever. But we feel like right now it's current to the state of where things are now. And so, yeah, as authors, we feel it's ready for last call.
Okay, then a question, to the room itself here. So, like, anybody objecting if we actually would start the last call from, like, let's say, like the middle of next week somewhere? No? Okay, then middle next week we'll do the working group last call on the document. Any other comments? No? Okay.
So next session is Bernie. It will talk about how to secure the link between the DHCP relay and the DHCP server.
Stand in the pink box.
We can take control of the point.
Okay. All right, so this draft is actually in the DC working group, and basically it updates, well, let me go to the next slide. It updates some of the text in some of the existing documents because during the IESG review of RC 7839, they raised some issues because of the nature of the data that was being exchanged. They were, they're holding up this document, which just added some new relay options, and we kind of said, well, this isn't fair to really block this because there's a lot of other relay options that have similar problems, and we don't really have any strong security between it. And typically, this is usually in an operational inside an operator's network where they're hopefully protecting it, their internal networks in good ways. And, I mean, if people can snoop the relay traffic and relay to server communication, they can probably snoop other things. So we got them to let us proceed, but I agreed to take on the work of improving the security between the relay agents and the DHCP server. And just as a background, RC 2131, which is the DHCP v4 specification, doesn't have any mechanism for security. RC 3316, which is the DHCP v6 specification, does, but it's only it's not a must or anything like that. It says you can use it. However, it also doesn't provide any authentication, any encryption for the communication. It just sort of says, you don't need it because most of the data isn't that that important to secure. Obviously, things have changed since that was written. So this draft proposes, and then it's now, as you'll see, it's with the ISG, must use IPsec for DHCP v4 and DHCP v6 relay to relay or relay to server communication. This stuff is out there, so it's not a big deal for us to require this. And we also require encryption as well. So it really changes from the DHCP v6 specification. It really changes you may use it into a must, and also adds the encryption. So, here are some of the IPsec details. They must use it. They must use encryption. We're also, while we say you can use manually configured keys, we really prefer people to use, the IKE v2 step and use either pre-shared secrets and hopefully even, full public key stuff. The current status is it has passed the working group last call. It was sent to the IASG. Technically, the IETF last call has ended. There were 2 reviews by GenArt and the security, and it's scheduled for telechat on the 4/13 call in the IASG, so hopefully it will get approved. But if people have comments, questions, or concerns, you can let the AD in the room know, or let me know, and we can work on it.
Any
Okay.
questions for Bernie? Because you finished, right?
I'm finished.
Okay. No,
That's it. Yeah.
So, any questions for Bernie?
Okay.
If
Great.
you don't
Thanks.
mind, I have one, if you don't mind. You can use from the HTTP relay to server a destination which is either multicast or anycast. Then you need GDOI and not IKE for doing it. Or you miss something.
So, there is the ability to configure multicast addresses for the relay forwarding addresses, or potentially anycast addresses or whatever. Obviously, there may be some, and we don't really mention those issues in the draft. If you make use of some of those things, if you don't have those, if you're using pre-shared secrets or whatever, it may continue to work. But depending on what you're using, there may be some issues. And it is maybe I didn't get your full question.
No, but my question is, as far as I remember, IKE v2 works only from unicast address to unicast address. Here you're sending traffic from unicast to anycast or multicast, so IKE v2 will not work in this concept.
Okay, typically most people don't use the multicasting or the anycasting capabilities for relay communication. I mean, most of the operators I know configure unicast addresses for that communication, okay? And they can do that because the relay agents have the ability to forward it on to multiple destinations, okay? So for protocols like the DHCP failover and things like that, you can configure the relay to send it to multiple destinations, and when the packet's sent out, they will duplicate the packet to those destinations.
Okay, then a suggestion maybe is to say in the text it's only when the relay destination address is basically a unicast.
Yeah, maybe there is something that we'll need to do to address that issue or question, or put the restriction on that, if you're going to use certain things, you cannot use the multicast or anycasting. I mean, anycasting might still work. I'm not 100% sure what the issues there are. But, okay.
Okay, thank you. Any other questions? Okay. Next person is Jérôme François. We'll talk about this famous question for us about dots signaling DOS over V6.
So thank you for the introduction. So this is a work that we proposed with my colleague Abdelkader, Marco, and Giovanni. And first of all, I want to thank you for the invitation to present in this group. So yes, so the idea here is, so we are involved in the DOTS working group, where the goal, of course, is to basically provide a mechanism, signaling mechanism between a client which basically knows there is an attack, a DDoS attack, and a server which will trigger a mitigation part. So it's really the key objective of the DOTS. Of course, there is a real different proposal in the working group with DOTS for the signaling part. We have, for example, the GTLS for communicating that there is an attack. And what we propose is not purely a signaling mechanism. We want to position our parts as a kind of backup mechanism, because the idea is that if you're under DDoS attack, maybe your network is congested and you want to pass a signal to send a signal that you're under that, but cannot go because, yes, simply your network is congested. So our idea is that we would like to benefit from already existing and forwarding packet into the network to embed some information about the attack. So it's like when you put a SSH message in the bottle and you send it to the ocean. So it means that basically we will not necessarily take the regular path between the client and the server, but we'll try to benefit from regular path. So if you look at it from a graph perspective, let's random walking graph. And so we want to add this auxiliary mechanism. So we want to, in particular, in the first instance of the attack, our colleagues have observed that there are still some packets that are able to be forwarded, and we want to take this advantage to put information. And we are seeing that using the hop-by-hop mechanism of IPv6 can be a good solution, because it means that we try to basically replicate this information into not all but many IPv6 packets that are forwarded. So it's kind, yes, of what you say, it's an opportunistic manner, because we will not, for example, when we initiate the process, we'll not put the information from a packet that goes to the client to the server, but from packets that basically goes to the client to another point in the network and so on. Okay, it will be just replicated at different points. So yeah, just maybe a figure to explain. So what we have here, we have, of course, a client and a server that want to, the client want to say that there is an attack ongoing. We have also gateway dots. So gateway, to be very brief, is kind of intermediate that the client can use between the, so the client can use before contacting the server. So the idea is that the client wants to connect either the server directly or the gateway. Okay, this is the common basis that we are trying to add now with dots. And then what we have on the network, we propose to have some kind of capable router for our option. So meaning that, of course, it has to be initiated by the client. The client will embed information in some IPv6 outgoing packet, or maybe create some at the beginning. Of course, this packet will live on their own. And then this will continue this, but then for each other packets that will go, for example, as you can see, for when there is a capable router, other packets that pass by can be then also marked with this information. So basically, this capable router will just store kind of information regarding the attack, and will encapsulate this information into other ones. So that's the principle. Okay.
So I think on the earlier slide about the hop-by-hop option, I think there's an assertion in your document that those are actually processed by most routers.
Sorry, can you?
Yeah, I think there's an assertion in your draft that the hop-by-hop option is actually processed by most routers.
Not really. We don't say that.
I'm pretty sure you do.
Yeah.
Joel Yegley. Yeah, so you said it utilizes the IPv6 hop-by-hop header, RFC 2460. This header has the advantage to be fully inspected by all network devices, as it is the first header in the IPv6 extension headers. So I think that assertion is unlikely to be held true, since I'm unaware of any ASIC-based router that honors hop-by-hop options by default.
Yeah, we know that.
Okay, then you should probably remove that assertion from the draft.
Yeah, but maybe it was in the first version. We did not. But the idea is that, yeah, we suppose that there will be some that can handle. Well, of course, it depends on the number. The most you have, the better it is.
Yeah, so like if I had to, for example, honor those by sending them to the software forwarding plane, I would never do that because, well, that's a DOS.
Yeah, okay, our assumption is that first, you're already on DOS. So I think you cannot be.
Yeah, you think I cannot be more DOS? Because that absolutely happens to me every day, which is that I get some and then I get some more, and after that I get more. So yeah, I think anything that actually increases my costs of processing packets when I'm under attack is definitely putting me in a worse situation.
Yeah, but depends who you're authorized to do so. I mean, we don't see that every client that connects to the network can do. It's only you have to kind of trust between client and server. I mean, it doesn't mean that, for example, for an ISP that every single user can send these options. It's really specific ones.
Well, it's specific to directionality, right? Because I either have to process hop by hop options on input or I do not, right? So if I'm going to honor a hop by hop option, like in order to decide that I'm going to authorize you to do that, I already have to find that the header exists.
Yeah.
Yeah. So
That's it.
like the only way that I could describe that basically is that my ingress ACL would be on a per interface basis, because otherwise I'm not going to parse the header.
Yeah, but you can do some.
So I've already incurred the expense, basically, before I decide what the IP address of the client is.
Yeah, you have
Yeah.
to have the ACL that
Okay,
checks that
so-
the header exists.
Like this is, like, I mean, sending the information upstream, I think is like a worthwhile thought experiment, and how to do that is pretty important. But like hop by hop sounds like a pretty scary way to do that to me.
Okay.
Wow, I'm not tall enough. Warren Kumari, so I have similar concerns. If I'm not really careful and I don't strip these out on sort of my edge or gateway, I'm now going to be signaling to everybody that, hey, I'm under attack. And if I'm also not really careful and don't filter them on ingress, this seems like an ideal thing for people to happily insert into the packets when they're sending me.
Yeah, I think you really need to be careful on the policy you have, yeah, or what you accept for the ingress traffic. That's for sure. This is basically this is the points that you are now addressing more on, let's say, practical consideration if you want to deploy such solutions. And as well, although yes, we present here, we'll present it 6 months as well to have more feedback regarding that. So yeah, we know that hub by option is really an issue from practical perspective. So then that's why on the mailing list we ask if from real experiments, if people really experiment it, and there are some feedbacks on other proposals that use hub by option, if they success or not. So yes, we're happy to get also this kind of feedback, not only about our draft, but also drafts that try to use and the problem they face. So yes, I will continue. Okay, so then we, of course, you have to we will not mark all packets. You have to kind of, you need some decision about the packets you mark. This is, we are proposing some example in the draft, but of course this has to be defined by, let's say, the user, I mean, the operators. All packets should be marked. Of course, the idea is to mark all in the first instance of the attack to have more chance, and then decrease the number of packets you mark to not overload the network as we say just before. But this, of course, is open how you define it. We don't say that we will define, we say that there is only one way to define. Okay.
And by the way, if you interrupt me, can you go back on the previous slide? No, the one you were marking all anycast packets or something like that. This one. Oh, yeah, this one.
Yes.
Point number 4. That's no way you can detect whether the destination is anycast or not, except by very specific configuration. Because there is no difference between an anycast address and a unicast address. So you need to get a configuration that tells this unicast address is actually the unicast, and so on and so on. I mean, not a big deal, but just be aware of this.
You're right. Thank you. Thank you very much. Okay, so then, yeah, we just the encoding of the options. So of course, we have some fields which will be with a fixed length, that otherwise with variable length. So we have TLD encoding. All the information is option, so nothing special here. So maybe as an example, of course, we implement different types of information. The server, so you want to reach for triggering the mitigation, some information about the attack, what is the host, which is the victim, the port which is under attack, and so on. Okay, everything should be included in the option, of course. We have also some kind of TTL that should be used to not continue to mark a packet at a certain threshold. So regarding deployment consideration, as we have already discussed, it's very hard to achieve because the hop by hop option is usually blocked. We are aware of that. So the idea is that, at least our rationale is that this option should be used by not, everybody, but really under kind of a circle of trust between some client and server. Maybe all of them operated by the same authority. And of course, we don't, because in the dots, there's already some scenarios that we describe with different domains. We are not targeting where we have inter-domain cooperation. Here we are really focusing on intra-domain because we don't believe that the option will be able to traverse from one operator to another. So yeah, that's so we will limit to this use case basically. Okay, so then of course we need to modify some kind of treatment that have to be done either by the client or the router, of course. So we need that capable routers are able to extract and store some information in order to encapsulate it. This otherwise it kind of works. And also from the server perspective, you have to decapture the information and transfer to the let's say application layer. So we got something back that it can be considered as a head of violation. We should not do that. Okay, we are not aware of that before the feedback, so we'll investigate this issue. We should use, for that, also using advanced socket API. Okay, because we have also started the implementation, but okay, we are currently doing it. So maybe in a few months we'll have some proof of concept. Okay, and so I think you have followed some conversation on the mailing list about the should we authorize or not in the session. It is can be considered as harmful, so it has to be done in a very careful mode, as we also discussed already a bit. We can use encapsulated mode, or in our case, as I say, we will target basically intra-domain. So at least we should say that in like in slice of network, you should know what are the possibilities you can do, for example, regarding MTU and so on, and you should be able to select if you can or not, let's say, insert the header. Of course, all these deployment considerations are the core of the work we are doing now and on our main thinking now to address them properly. Yeah, I think I'm done. Of course, yes, we have also security consideration in the draft. So of course we need to kind of checking that the client is really the authorized client to do so. As we said, we should limit who can first initiate the process by creating the first packet. And okay, we have also some signature that should be used to verify the identity at the server side then. Yeah, basically that's it for security conceptual. But yeah, the main focus here is more about how we can practically deploy it. And yes, we are really happy to have any feedback about that. And I mean about your draft, but as I said, also about other people that propose some draft using hop by hop as well, or try to do some experiment with hop by hop. So I'm done.
Okay, any questions for Jérôme?
Jelinkova. Actually, I like when people trying to find useful applications for extension headers, right? We need a killer app, so people start using them. However, I do have concerns here. First of all, as it's been said, you already under DDoS, you drop in traffic, and you insert in header, which increase the probability of this traffic to be dropped, right? Because the measurements we've done shows that routers do drop packets with extension header, right? So basically, you're making the situation for the traffic worse. And second concern about, yes, header insertion. I'm not very concerned about MTU, because if it's your domain, you probably know your MTU. However, what do you do if you need to send ICMP back?
Yeah.
So do you want your router to spend some time and resources on removing the header and send the packet back as it enters your domain, or what you're trying to do here?
Okay, yeah, for the second question, actually, we didn't really think about it yet, so thank you for the feedback. I have no, yeah, maybe we just remove the header, but I have no clear answer. No, I think we have to.
But Jen, if you don't mind, if you arrogate, if you are under DOS, you will never send an ICMP back. You have other things to do, though.
I'm not sure this particular router might not be actually under DOS, right? What we're doing, I'm probably missing the scenario here, but we have a client which is under the DOS, then it sent packet, and the packet might probably not necessarily going through overloaded router. And the router probably processing this packet, and for example, hop limit is now 0, right? So we need to send ICMP back, or we need to send ICMP back for some other reason. And let's assume router does have resources to do this, because yes, otherwise indeed it will be just silently dropped. So we either sending some strange packet back and client would not recognize it, or we need to spend additional resources on crafting it, reverting it back to our original state, which might be tricky.
Right, thank you.
Oh, yeah, thank you for the feedback. I think, yeah, regarding your first question, I think it's was the same. Should we, regarding resources, should we just maybe, okay, we know that it will provide some overheads, that's for sure. I mean, we are not even it in the draft, we know. But yeah, the idea is that we try to find a solution that you are able to send your signaling before you cannot at all do, and then it's probably too late.
So, sorry, I just briefly read the draft, but I'm not sure exactly what you want the routers to do when they see those hop-by-hop headers. Because I understand you're trying to signal something to the server,
Yeah.
what the routers are supposed to do. Let's say my intermediate router receives the packet with hop-by-hop.
Yeah.
What's the action?
They are supposed to, let's say, store this information and embed the information in all the packets.
Okay.
So the idea is what you say. The idea is not necessarily to use the path which can be congested by the attack, but try other paths in a kind of opportunistic manner, such that it reaches either the server or either a gateway. So, okay, some assumption is that we should have more gateway into the network that can then relay to the server.
Okay.
Other question from Jerome? Or any hint? By the way, Jerome, I don't know whether you know the in situ OEM working group, which is doing kind of things vaguely related. You may want to go there. In situ, IOM.
Okay, thank you.
Welcome. Okay, next speaker is Richard Barnes. He will talk without slides, which is quite unusual at the IETF, but I think it's a good performance, about ACME, explaining what is it, the architecture, and then a Q&A on this, in my opinion, very important protocol.
Hi, I'm Richard Barnes. Raise your hand if you've heard of ACME already. Okay, great. All right, we're done. Thanks. Okay, so I'm directing my vision to you. So we had this problem in the web for a while where, we want to get all the websites encrypted, but in order for a website to be encrypted, it's got to have a certificate to prove its identity. And for ages, the process of getting a certificate and provisioning it to a web server was an entirely manual or mostly manual process. And so ACME was an effort to automate the provisioning of certificate, the management of certificates, so that we could have automated certificate provisioning stuff and scale up the encryption of the web. So this is the technology that underlies Let's Encrypt. That was kind of the first use case for it.
we developed the first version of Acme to get Let's Encrypt started. But the idea of the working group here is to expand that out, and so to make it suitable for use with other CAs and get the entire PKI that serves the web and other internet applications upgraded and automatable. So the primary use case that Acme addresses is this case of DNS-based certificates. So, websites authenticate their domain names, and so Acme provides mechanisms for an applicant for a certificate to first request a certificate and show up at the CA and say, I would like a certificate with this collection of domain names. The server/CA responds and says, okay, you need to prove to me that you own those domain names, because that's what CAs do. And then Acme provides a few different automated mechanisms by which the applicant for a certificate can prove that it owns a given domain name. It can set up an HTTP server that responds to a certain structured query. It can provision some DNS records. There's a TLS-based dance, things like that. So the idea is that the applicant configures something under that domain name. The CA does a probe to see if that thing had been successfully set up, and if so, considers that the applicant to have proven he owns that domain. And once this dance has been completed for all of the names that are requested in the certificate, the CA can issue the certificate. So the nice thing about Acme, so that's kind of the basic flow. Request the certificate, prove you own the names, get the certificate. That's about the entirety of the protocol. There's a revocation thingy, so you can ask for a cert to no longer be valid, but that's kind of a different part of the life cycle. Nice thing about Acme is it's extensible in a couple of ways. So it was built with an extensible identifier space, so you can define Acme for other types of identifier if you care about MAC addresses or IP addresses or telephone numbers. We have drafts right now for telephone numbers, for STIR, and for IP addresses for something. I don't know why they want to use it. But in general, you can define a new class of identifier for Acme, but then you also have to define some new ways to prove you own those identifiers. So the telephone number draft, for instance, defines a way you can prove you own a telephone number using an SMS-based interaction. You put this content in an SMS and you respond to it, and then you prove you own the phone number. So yeah, this has gotten obviously a fair bit of usage in the web. I think Let's Encrypt has issued like 50 million certificates with it. They're now the number 15 or 20 or so CA in the world by usage. They're the #1 CA in the world by number of certificates. Hoping that a lot more CAs will use this, and it's getting used in a couple of different, rewinding a bit, even in the context of Let's Encrypt, there's been some interesting uses for it in sort of embedded cases. So in web cases, even in web cases, it's been kind of interesting. It's gotten into kind of embedded operational stuff. A lot of that major growth, those 6- and 7-figure numbers have come from hosting providers that have integrated Let's Encrypt support into their hosting platforms. So like DreamHost right now, if you spin up a host on DreamHost, literally you can tick one box and they'll do HTTPS hosting, using Acme to talk to Let's Encrypt to get the certificate to do the HTTPS. So there's been a few of those types of deployments in the web. My other favorite example is that Free, the ISP in France, has been using Acme to provision Let's Encrypt certificates to their set-top boxes to support an HTTPS interface there. They have a slightly more complicated setup where the set-top box talks to a central controller that owns the DNS zone from which the names are provisioned for those devices. But basically, there's a little proprietary internal dance between the set-top box and central controller, and then the central controller does the Acme dance with the CA and provides the cert back to the set-top box. So there's some interesting embedded applications kind of starting to come up that are slightly broader than the web case. But wanted to sort of throw that out because I know you guys are more in the operational space and have some probably different use cases for this stuff beyond just the general web. So that's the overview. Q&A. Questions, comments? IETF status-wise, we just finished working group last call, and we'll be talking on Thursday morning or afternoon, whenever the Acme meeting is on the schedule, about whether to hold the draft to get some more implementation of the current revision, or to go ahead and send it to the IESG. But anyway, it's basically stable and done. IETF last call coming soon. So, any last comments? Now's the time. Any questions, comments?
Jeff with Cisco. This is just a brainstorming out of the blue. I'm not familiar with the protocol, but you provided a good description of it. Just curious. I mean, because it's automated, I love that part. Security's always been hard, but if you can automate it, it's awesome. What about using it to help automate DNSSEC deployments or things like that? Or that's too far-fetched? Because DNSSEC is still very limited in deployment around the world, so.
Yeah, I think it's solving a slightly different problem, right? Because you're imagining, securing kind of updates to the zone that would then get secured with DNSSEC. Yeah, I think there you're kind of presuming that someone has a way to authenticate that they're authorized to make those changes. Here you're kind of starting, in the Acme case, you're starting out from kind of zero presumption. Some client walks in off the street that the server has no prior relationship with. And the server has to verify any authorization that it grants to the client. So if you squint your eyes hard enough and use your imagination, there might be some other applications like that where you want to kind of build up authorization. But I'm not immediately seeing how that might apply to DNSSEC.
Thank you.
Yeah, sure.
Hi, Doug Montgomery. Yes. So does the security considerations section talk about this issue that if I have an outsourced DNS, I assume the proof of ownership is by inserting.
It's empirical.
It's empirical.
Yeah.
Right. So can you talk about that issue? Is that if I'm using an outsourced DNS provider, well, you could say that they can always screw me over in the DNS. Now they can screw me over and provide a certificate that makes it look like I'm securely screwed over.
Yeah, the security considerations addresses, in general, the vulnerabilities that arise from the verification channel. So if you kind of have the abstract view of this, like there's kind of two channels by which the CA and the applicant communicate. They communicate over ACME, over HTTPS channel. And then there's some non-ACME thing that the CA does to verify that the applicant has the name. And, whether that kind of by assumption has no security to it, that verification channel. And so you're open to things along the path you're claiming that authorization. So there's some tools in that we described in the document for making that job harder for the attacker there, but we recommend things like doing DNS resolution from multiple vantage points. But there's still that issue of if someone attacks you at the registry or at the registrar, then yeah, there's not much you can do with anything that is empirically based.
So Warren Kamari, don't most of these vulnerabilities already exist with normal CAs not using ACME? Like most of those same ones they could do anyway.
Absolutely, yeah. This is, in large part, all that ACME is doing is automating existing practices of CAs. It's a marginal incremental benefit because there's a lot of validation that is not even empirical to the degree ACME is empirical. Like a lot of validation is done by sending email to the registered contact and who is, which is a different set of vulnerabilities, but there's not even a direct tie to the technology. So yeah, several of the mechanisms we've got in ACME are kind of built out of things that are already in use in the pre-ACME PKI. I have some small degree of pride in that some of the mechanisms that we've got in ACME, the analogous things in other CAs have deployed, have had some vulnerabilities that we managed to catch in ACME. And we've gotten some analysis from INRIA and Karthik, the guys that do formal modeling, so we have some confidence this thing hangs together and actually provides the guarantees we think it does.
Sort of another question along that lines, you said there's like a profile for getting a certificate for an address or an address block. how do those folks empirically prove they have?
That draft is about 48 hours old.
It's a work in progress.
I think basically what they've proposed is, well, I think they've proposed to reuse some of the HTTP and TLS options. They defined a new one. I'm forgetting what that new one was, but they noted you could also reproduce redo the HTTP and TLS based things here, except you just connect to an IP address instead of connecting to a domain name using those protocols. There's obviously a ton of security considerations to be addressed for that draft. Like I said, it's brand new. Yeah, Doug, since I noticed your USG, I associate you with USG. Other thing you could envision, yeah, right. One other thing you could envision here was doing this. If you wanted to do this for like PIV provisioning, you could define like an email identifier type and do some verification, or perhaps have some authority that could prove they could grant authorization to use email addresses. Again, there's a few unexplored use cases here. We've solved one big one. We've addressed one big one, but there may be others. Anything else?
One quick question. Are you serving OCSP on any kind of certificate checking, rotation?
Me personally?
No.
So OCSP is kind of external to this, to Acme. I think the idea is that a CA has to run multiple services in order to kind of make the whole thing work. In addition to doing issuance and notification, interactions with the applicant or owner of a certificate. It's got to have interactions like OCSP or issuing CRLs with relying parties. Acme is kind of designed to dovetail well with those without replacing them. So, Acme has a revocation endpoint where an authorized party can request that a certificate be revoked and provide a revocation reason that can then go into an OCSP response. It's also possible within Acme, and I think Let's Encrypt has support for this, to request things like the must stateful extension. So to put things in the certificate that would make revocation more efficient.
Okay, thank you. Any other questions for Richard?
All right. I'm around all week, so if anything else comes up, say hello.
Okay, thank you. Where are the blue sheet, by the way? If you can bring it to the front.
Yeah, and then also actually, so we're at the end of this particular, gathering here. But at the total end, I also, would like to make like one small announcement here. So I would like to thank Joel here for, standing with us, in the ups and downs of the working group. Being a motivating kind of inspiration, which was needed from time to time. So again, thank you, Joel. And at the same time, would also like to welcome Warren here, as the new shepherding AD for the working group. He's familiar with the work, he's been sitting here together with me, so he knows, where we can bring all of this stuff.
Yeah, I think you're in pretty capable hands here. So I don't imagine you'll miss me that much. Thanks.
Perfect. Can you take it? Okay. Thank you. Meeting is adjourned. Enjoy your evening.
Presentation.